Solar storm warnings and why space weather, that what happens in space, is the greatest hazard to humanity when humanity is in space. Solar storms and charged particles and cosmic rays streaming from the sun and our universe pose a great threat to humanity's space-faring ambitions. Space travel is going to need a tremendous amount of protection. This is what a physicist has astonishingly warned. Sebastian Ketley of Express UK reports the solar storms are byproducts of ions and electrons emitted from the sun, and they slam into our planet at great speeds. On Earth's surface, we're mostly protected from this solar radiation and even cosmic rays by Earth's natural magnetic fields, or Earth's magnetosphere, except when we have a minimum, and then even the magnetosphere, for some reason, which the scientists don't even know, is decreased, meaning that there's more cosmic rays coming in. Now, in our space weather, solar and geomagnetic storms in outer space can wreak havoc on satellite systems and spacecraft operation, if, of course, they're hitting them. Now, until recently, scientists believed these storms were in the region of space around Earth where they did not directly cross paths with satellites. But researchers at the University of California, Los Angeles, UCLA, found that solar storms can strike much closer to home. This discovery creates problems because it suggests that space weather can directly interact with spacecraft such as weather or GPS satellites. Now, Professor Vasilis Angelopoulos from UCLA said, by studying the magnetosphere, we improve our chances of dealing with the greatest hazard to humanity venturing into space storms powered by the sun. Now, of course, we're talking about cosmic flares, solar flares. According to the U.S. Space Weather Prediction Center, SWPC, powerful solar storms can have a disastrous effect on aircraft systems, power grids, and technology blackouts. And weaker storms can be disorienting for animals that rely on their inner compasses to navigate our Earth. Now, the more enjoyable side effects of space weather include the northern lights, as we know, the aurora borealis and southern lights. These are the beautiful streaks of colorful gases excited by charged particles from the sun. Professor Angelopoulos led this new study by NASA's Themis mission into the effects of solar storms and what they can have on Earth. Their findings were published in the journal Nature Physics, January 13, the day before yesterday. When a powerful solar storm struck the planet in 1921, the U.S. faced disruptions in its telegraph communications. The storm also triggered power outages in New York City that led to the NYC train station even burning down. Researchers also are concerned for the safety of astronauts. There are currently 6 people living on the International Space Station, the ISS, and humans will be returning to the moon as early as 2024. Now, alien worlds such as the moon or Mars in our solar system are very poorly protected from the effects of space weather. If we're exposed to blasts of solar radiation, it can prove dangerous in the long term, even with small doses. In 1972, one example, NASA's Apollo 16 and Apollo 17 narrowly missed being hit by particles ejected from a solar flare. And lucky for them, the solar storm struck right in between these two missions. NASA said, the solar storm of August 1972 is legendary at NASA because it occurred in between 2 Apollo missions. The crew of Apollo 16 had returned to Earth in April, and the crew of Apollo 17 was prepared for a moon landing in December. And according to UCLA scientists, these solar storms could strike much closer to home due to an effect dubbed magnetic reconnection. When energy carried by solar winds is transferred into the planet's magnetosphere, it's turned into heat and accelerates particles to great speeds. And these particles excited in the magnetosphere of the Earth, much like the ones trailing from the Sun, can be harmful to human DNA and even satellites. The risk is that the particles can increase the chances of radiation poisoning and cancer in unsuspecting astronauts. What can they do? They can't do much about this. Professor Angelopoulos said, only with such direct measurements of magnetic reconnection and its resulting energy flows could we convincingly prove such an unexpected mechanism of storm power generation. Capturing this rare event nearer to Earth than ever detected before forces us to revise prior assumptions about the reconnection process. Now, according to NASA, and I'll leave a link below for you, it says how to protect astronauts from space radiation, and they're having Mars here as an example. On August 7th, but they do relate to the solar flare of 1972. On August 7th, 1972, in the heart of the Apollo era, an enormous solar flare exploded from the sun's atmosphere, and along with a gigantic burst of light in nearly all wavelengths, this event accelerated a wave of energetic particles, mostly protons, with a few electrons and heavy elements mixed in. This wash of quick-moving particles would have been dangerous to anyone outside Earth's protective magnetic bubble. Luckily, Apollo 16 crew had returned to Earth just 5 months earlier, narrowly escaping this powerful event. In the early days of human spaceflight, scientists were only just beginning to understand how events of the sun could affect space, and in turn how that radiation could affect humans and technology. And today, as a result of extensive space radiation research, we have a much better understanding of our space environment, its effects, and the best way to protect astronauts, all crucial parts of NASA's mission to send humans to Mars. Now, they're talking here about the Martian film and everything. Space radiation, they said the environment will be a critical consideration for everything in the astronauts' daily lives, both on the journeys between Earth and Mars and on the surface. According to Ruth and Lewis, architect and engineer with the Human Space Flight Program at NASA's Goddard Space Flight Center in Greenbelt, Maryland. He says you're constantly being bombarded by some amount of radiation. Radiation at its most basic is simply waves or subatomic particles that transport energy to another entity, whether it's an astronaut or a spacecraft component. The main concern in space is particle radiation. Energetic particles can be dangerous to humans because they pass right through the skin, depositing energy and damaging cells or DNA along the way. This damage can mean an increase in risk for cancer later in life, or, at its worst, acute radiation sickness during the mission if the dose of energetic particles is large enough. Now, fortunately for us, Earth's natural protection blocks all but the most energetic of these particles from reaching the surface. A huge magnetic bubble called the magnetosphere, which deflects the vast majority of these particles, protects our planet, and our atmosphere subsequently absorbs the majority of particles that do make it through this bubble. And since the International Space Station is in low Earth orbit within the magnetosphere, it also provides a large measure of protection for our astronauts. We have instruments that measure the radiation environment inside the ISS, where the crew are, and even outside the station. The ISS crew monitoring also includes tracking short-term and lifetime radiation doses for each astronaut to assess the risk of radiation-related disease, although NASA has conservative radiation limits greater than allowed radiation workers on Earth, as astronauts are able to stay well under NASA's limit while living and working on ISS within Earth's magnetosphere. But a journey to Mars requires astronauts to move out much further beyond the protection of Earth's magnetic bubble. There's a lot of good science to be done on Mars, but a trip to interplanetary space carries more radiation risk than working in low Earth orbit. A human mission to Mars means sending astronauts into interplanetary space for a minimum of a year, even with a very short stay on the red planet, nearly all of that time they will be outside the magnetosphere, exposed to the harsh radiation environment of space. Mars has no global magnetic field to deflect energetic particles, and its atmosphere is much thinner than Earth, so they'll get only minimal protection even on the surface of Mars. And this, of course, goes also for the Moon. Now, we know that in the next decade or so, I think it's by 2038, Russia said it wants to place an international space station in the orbit, lunar orbit. Just like we have an ISS here for Earth, they want another one to be in lunar orbit. And of course, that will mean that they there on that will also have tremendous amount of radiation exposure. So there's a lot to be done trying to protect humans and the machinery from all these solar radiation and cosmic radiation as well. So we have the solar radiation, but there's a second source of energetic particles, and it's harder to shield from them. These are the galactic cosmic rays, often known as GCRs. The cosmic rays, they're particles accelerated to near the speed of light that shoot into our solar system from other stars in the Milky Way or even other galaxies. Like solar particles, galactic cosmic rays are mostly protons, but some of them are heavier elements ranging from helium up to the heaviest elements. These more energetic particles can knock parts apart atoms in the material they strike, such as the astronaut, the metal walls of the spacecraft, habitat, or vehicles, causing subatomic particles to shower into the structure. This secondary radiation, as it's known, can reach a dangerous level. There are two ways to shield from these high-energy particles, and their secondary radiation use a lot more mass of traditional spacecraft material or use more efficient shielding materials. Now you can imagine how heavy the spacecraft would have to be to shield from cosmic radiation. It would be virtually impossible to lift it off of Earth and into off Earth's atmosphere if it's that heavy. Now, the sheer volume of material surrounding a structure would absorb the energetic particles, the cosmic rays there, and their associated secondary particle radiation before they could reach the astronauts. But using sheer bulk to protect astronauts would be prohibitively expensive, since more mass means more fuel required to launch. Using materials that shield more effectively would cut down on weight and cost, but finding the right materials takes research and ingenuity. NASA is currently investigating a handful of possibilities that could be used in anything from the spacecraft to the Martian habitat to spacesuits as well. The best way to stop particle radiation is by running an energetic particle into something that's a similar size. Otherwise, it can be like you're bouncing a tricycle off a tractor trailer. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.